Before moving forward, I would like to tell you about our brand new offering at Algocamp around the advanced Spring Boot backend development cohort. So we were getting a lot of requests to actually launch our next iteration of the Spring Boot cohort, and here we are. This one is far more bigger and better than the last one, and trust me, if you are somebody who is looking to start their journey in the world of Spring Boot in the backend ecosystem, or maybe you already know some things about backend development, maybe in Spring Boot or maybe in some other tech stack, this is going to be a one-stop solution for you. We are going to talk about everything from the absolute beginner level to the advanced level in Spring Boot. We are going to talk about how exactly you can set up your backend ecosystem and backend projects in Spring Boot. We are going to take a microservice driven architecture and build different projects, including an Uber app, including Airbnb app, payment wallet like Paytm wallet app, and many more. We are going to talk about how exactly microservices can actually communicate with each other in synchronous and asynchronous fashion. We are going to see a lot of interesting microservices pattern like CQRS pattern, Saga pattern for distributed transaction, how you can implement Saga pattern through orchestration and choreography, how Saga pattern is going to help you with respect to the implementation if you compare that with two-phase commit, how you can implement each one of them, what is the outbox pattern, how exactly event sourcing is going to work, how you can integrate Kafka for your event sourcing, and whatnot. We are going to see so many interesting database concepts like how exactly NoSQLs are internally implemented using LSM trees, what are write-ahead logs, how you can replicate your databases, how you can shard your databases, how you can design a good database schema, and whatnot. All the topics that we are going to cover must be listed in front of you on the screen here. What I can say is that this course is going to be one-stop solution to become an advanced backend engineer in Spring Boot. This is definitely going to demand some good time commitment from all the students who are interested, but trust me, this is going to be one hell of a ride. So what are you waiting for? Do check out the link in the description section below and read the complete end-to-end syllabus of what we are going to cover in the Spring Boot cohort. You can actually use the coupon SPRING2025 to get maximum possible discount on the course, and I'm really excited to see you guys in the cohort, right? Do check out the link description section below, and let's get back to the video.
Hi everyone, welcome to the new set of tutorials in the Spring Boot series where we are going to sort of work on a new project which is sort of going to be a hospital management system based on the CRUD APIs, right? So by far at this point of time you already know the basics of I would say Spring Boot, how to set up a new project and everything else, right? But that's not really enough. You need to know other concepts that comes with it as well, which are sort of very used popularly in the industry as well, or whenever you'll join the company, you'll be using these concepts very frequently if you work with Spring Boot. So we are going to learn those projects, but while making a project, because that's actually the best practical way to learn. So for our project, we are going to build a hospital management system, and this particular video is going to just highlight over what exactly we are going to build. Okay, it will talk about what exactly are going to be the key features and the functionality of the projects, as well as with that, we will also sort of define a API contract, right? When I say API contract, we will sort of define already the APIs which are going to be in our project. Okay, so we'll highlight them, right? And then so that we have the right expectations when we work on the project. This is usually the responsibility of either the product managers, right, or the product designers to sort of take care of these things, right, before we actually work into the project. So I have already predefined that for us, right, and then we are going to directly jump on implementing it. The first is going to be four sort of entities or four sort of modules which are going to be in our project. Okay, the first is going to be a patient. Obviously in hospital you are going to have patients, so we are going to have like a patient profile management kind of like a section where we will be able to sort of manage the profiles of the patients, including their personal information, their medical history, and their treatment plans. Then we will have a doctor profile management. So we are building a management system, right? So all the activities and the operations that you could do with all the entities in a hospital, we'll basically sort of be building APIs for that. The next is going to be again a doctor profile management, which will allow us to manage doctor profiles, including their personal information, their qualifications, and their specialties. Then obviously, if there's a patient, is there a doctor, right? The patient would like to be able to schedule appointments with the doctor. So we are going to build a system where a person will very well be able to allow and, allowed to schedule and reschedule their appointments, and they will have sort of automated notifications also sent to both patients and doctors whenever there is a successful appointment being scheduled. Apart from that, I have also added another functionality which is going to be related to billing and payment. Okay. Now, this sort of management will allow us to take care of the billings part and the payment part. Whenever there's a successful appointment and it goes through as well, there would be a bill generated and you would have to take care of the payments as well. So with this, we will try to integrate something where we have automated invoice generation and tracking of the payments which have been done so far and how far a payment is through in the process. So this is typically what the features and the functionalities are of our hospital management system, which we are going to build. Next, let's quickly go through the sort of API calls as well that we would want to put. For a patient, I would want to have an API where I can create, or the receptionist or the admin can create a new patient record. If they want to retrieve a list of all the patients, they could do that. If they want to retrieve a particular patient based on the patient ID, they could do that. If they want to update any details also, they could do that. And if they want to delete a specific record of a patient, they should be able to do that as well. Now for a doctor, pretty much the same only. If I want to create a new doctor record, I want a list of all the doctors, I want to retrieve a doctor based on a specific ID. And if I want to update any record or if I want to delete a doctor's record, I should be able to do that. For appointment, right? First, again, if I want to create a new appointment, I want to retrieve a list of all the appointments, right? And if I want to get the appointment based on an ID, and if I want to update it or delete it. Pretty much the basic CRUD operations that could be done is what we are going to implement, right? And similarly for the billings also, it goes pretty much by the same fact. Okay, I'm also assuming you already know about the REST API, so we're not going to go too deep into talking about post, get, put, delete. That is being assumed that you already know, right? And that is what we will have to implement. This is going to be a basic project. Feel free to add more and more layers into it. Feel free to add more complexities to this project if you feel like, right? But my job with this project will be to help you build a basic architecture on what basically hospital management system could look like, and how would you generate a simple project with CRUD APIs, and then how do you really go about adding more complexities to it as well. Okay, so I feel like with this video we have the right expectations in our mind. We know exactly what we are going to build, and the next set of tutorials we are going to go hands-on and try to build our hospital management system. Okay, I hope all of you are really excited for the next set of tutorials. I know I am, and I will help you build a very nice, optimized, formatted code project that you could build. Thank you. All right, hi everyone, welcome to the next tutorial on the series where we are building a hospital management system, right? And this is going to be the very first hands-on video where we are going to get started on building the project. I believe so far you all already know how to set up a basic project on Spring Boot, so we're not going to revisit all of that. That's why I already have this project ready with me, right? When you're building a new project here, I've sort of named it .demo, but feel free to sort of rename it to .hms, like a hospital management system app or anything that you really want, right? And under this, we will have a main, I would say, file over here. If you really want to test out if everything is working fine or not, you could just simply, I'm sure you must have already, like, you know it as well. You could just write Spring Boot application, and then you could define like a REST controller, okay, over here, and post that you could, like, here just mention Spring Boot Spring application dot run, and then you could just do a simple Spring Boot app dot class. Okay, and if you want to see if your API like a simple call is working or not, you could just like define a function which is sort of going to be a get call over in this case, and you could return something like hello world over here. Okay, so you could do something like this, and on top of that you should add get mapping, so to know really that this is going to be a get call. Okay, so once you have this simple thing in place, right, you could just simply try to run this and see that you should not be facing any problems or any issues. All right, this looks good to me. We could like maybe have a new window, and we will try to hit localhost 8080, and you can see like a basic simple server setup is working fine, and that's how you know that your simple project setup is working well. You could either set up the project all by scratch using IntelliJ, or you could really use, I would say, the Spring Boot starter as well. That will set up the basic project for you. Okay, but so far this is working fine. Another thing that I would like to tell you as a prerequisite sort of to build this project is to have MySQL installed in your systems. Okay, because MySQL is sort of the place where we are going to dump all our hospital management data and create our tables corresponding to that as well. Okay, so it is important to know that we have that MySQL ready as well to make sure everything is working fine. Okay, so make sure you have that. Try to run, there are very good documentations available to download MySQL and to set up it in your systems. Feel free to use them, right, and which will set up MySQL for you. Okay, now post that, once you do complete this and when you know it's working fine, you could just go to build.gradle, because I told you, right, we will be using MySQL and like, you know, a bunch of other dependencies, so we will have to add them as well. By default this should pretty much already be there. If any of the lines are missing, feel free to add it. This is going to be a slightly new part. By default you will not have so many dependencies. I have added a couple of them over here. You will have to do the same as well, right? And by default only the starter web should be there if you use that while doing the Spring Boot starter implementation, right? That is pretty much what you should have. The others you will have to add. I'll just quickly explain those as well. This is going to be again the dependency which will include all the libraries that you actually need to build a web application using Spring Boot. That's why it's called starter web. Okay, it includes, you know, Tomcat server, Spring MVC, and other related dependencies as well. Okay, this compile only, and this is sort of going to be very new and very, very useful when we will define the models as well, right? So just to tell you a little bit, Lombok is basically a library, right, that will help you to reduce the boilerplate code. Okay, since we are talking about it, I will write a little as well. Lombok. So Lombok is a library that helps to reduce boilerplate code in Java classes by automatically generating getters, setters, constructors, and other common methods, okay, which you will need using compilation. Usually for a class you would define getter, setter methods, right? You don't have to do that if you have Lombok. Okay, the reason why I have added a compile only over here, keyword over here, that means that it is going to be needed only during compilation and not during the runtime. Okay, then we have this Spring Boot DevTools, right? This Spring Boot DevTools basically provide additional development time features such as, you know, automatic application restarts, live reload, enhancement development experienced. Okay, they are used using development. This is not going to be used during when your code is in production. Okay. Next is the annotation processor. This process basically generates the metadata files. Okay, so we have this application.properties file, right, which I will come to. This application.property files basically have a bunch of configuration about your user details to connect to MySQL and a bunch of other things as well. Okay, so basically this process, this annotation processor allows to generate the metadata files based on what the configurations I have provided in my applications. Then we have data JPA, right? This is basically, I would say, this starter sort of includes all the dependencies required to use this one. Basically required to use Spring Data JPA. Okay, so we will have data access layers in our project, right? There will be a layer which is going to access the data through the database, simply called data access layer. Okay, so on that data access layer you will have a bunch of dependencies, right? So this basically starter will help you to get those dependencies. Don't worry if it feels a little overwhelming right now. When we will actually implement, no, you'll see that it's pretty straightforward. But just because we are adding it here, I want to take a few minutes to explain this as well. Okay, next is sort of going to be this is also pretty much the same. This I think I got added twice. This I'm removing. Then we have runtime only. This basically dependency provides the MySQL JDBC driver. Okay, so basically if you want to connect your Spring Boot application to interact with a MySQL database, you use this dependency over here. It is marked as runtime only because the MySQL connector is only needed at runtime when the application is actually executing, not during the compilation or the development. Okay, so make sure you add all these dependencies and then you sort of run them so that these get integrated into your project. Okay, so first step was to make sure that a simple hello world sort of like an application is running, and then because we are going to start writing model classes now, make sure all these dependencies are there in the project. Okay, once you have these two steps, then you are sort of ready to start writing the model files now, and then with that define the connecting, I would say, attributes and the connecting key value pairs in the application.properties file as well. Okay, so make sure till this point everything is running fine and you're not facing any issues, and then you'll be good to go to move to the next part of the code. Okay, we'll keep it this much for this video and I'll meet you in the next one. All right, now that we have in the last video already set up our basic Spring Boot server, we're going to go ahead now and basically, like I told you, in our project, we're going to be using MySQL, right? So first of all, make sure MySQL is pretty much connected, right? If you want to start a MySQL server, for Mac, the command is mysql.server start, right? MySQL is already running for me, so I'm not going to run this command, otherwise I'll try to connect again, right? But this is how you would know that MySQL is there in your systems or not. And then if you want to log in into your MySQL server, you will simply do this and then you will enter your password and there you go. You are into your MySQL server where you can write the queries and define the databases. Okay, another thing that you could do is you could have MySQL Workbench in I would say installed in your systems, right? MySQL Workbench is simply a tool which sort of provides you a better visualization for all the databases and all the tables that you have in your database. Okay, so you could have MySQL Workbench installed as well. Right now, a couple of properties that I will define over here are going to be something like this. First, I will have to define the configuration of the database, right? What exactly is going to be the URL of the database is what I will define over here. So you write it something like this. JDBC is the connector, right? Which is sort of creating a connection. So you do JDBC. You write JDBC colon, the type of database that you have, colon, and then you will mention localhost. My DB is running on 3306. So I will mention that URL and then the DB name. Let's say I create hospital DB. Okay. Then you will do spring dot data source dot username, right? You will mention your username over here, whatever is your username. For example, mine is root. Then whatever password you have defined, data source dot root is equal to root itself. So you will define the password, and then so this was already there, right? The URL part, this basically property specifies the JDBC URL for connecting to the MySQL database named hospital DB, which is running on the localhost 3306. The format is very simple. You start with JDBC colon followed by the database type and then the host name and the port and finally the database name. Then we define the username to be used when connecting to MySQL. In this case, we set it to root. Then we set the password. For example, my password is also, let's say, root. So I will set to the root password only. Now then I will do spring dot jpa dot show SQL equal to true. Okay, what does this property basically instructs Spring Boot to log the SQL statements that is generated to the console. So if anything is happening, any command is being executed, it will simply be logged into the console. Okay, setting it to true basically enables SQL logging, okay, which can be useful for debugging and understanding the database interaction and performed by the application. Okay, then I will do spring dot jpa dot hibernate dot ddl auto update. Okay, this property basically configures the behavior of hibernate automatic schema generation. So what will happen is now you will see, like in a while, you will see that I will create a models folder, and inside that I will add all the entities: bill, appointment, doctor, patient. This command will automatically, based on what the model files I will define for all the entities, it will automatically create the table for that. Okay, so this is property configures the automatic schema generation feature, and because I have added it to a update value, right, that means I am telling Hibernate to actually create or update the table, right, or update the database based on the entity classes which are defined, okay, in the application. When I will see the entity, when I will show you the entity classes, you will get more idea. Okay, so just for the time being, just understand this is something going to be over here. I'll come back to this statement again. I will explain Hibernate. I will explain what is this doing once I have written the entity classes. Okay, so go on the models over here. First create a package which is going to be models. Right, and inside that you create a new file which is, let's say, a patient. Okay, now this is going to be a public class patient. Let's say now I do define properties: private long ID, private, I'll just like zoom this up, private string name, private string, like a patient will have a gender, private int age. Okay, now ideally what you should be doing over here is that, let's say, if you really have to access name, so ideally you should like define a function like this, right, and then return name, something like this, right? And even if you have to like set a setter function for this, you will have to create functions. How does Lombok really help you over here is that on the top of the file you could just define something like this. First of all, mention that this is an entity, right? This is going to be a separate entity. The moment you mention entity, a corresponding table should sort of go inside, I would say, the DB, right? When you say a builder over here, that will sort of introduce that as well. If you feel like reading about it, you can sort of go ahead and read as well. This is sort of be implementing the builder pattern whenever an object for this class is created, right? You can add, so you don't have to necessarily add constructors also, right? For this particular class, this line will automatically generate a all args constructor. Okay, all args constructor means that if you have to create an object of this class, you will have to sort of use a constructor which will be requiring one argument for every field which is mentioned over here. So technically a constructor will 4 arguments, but you don't have to write it. This annotation will help you. Then you could say no args constructor also. That means a object of this class is created without passing any arguments in the constructor as well. Sort of like this. Public patient, a no args constructor. But you don't have to really write this. Why? Because no args constructor is already written. That's why it's throwing error also. Okay. The moment you do getter, right, it will get you a getter function for all the fields. So you don't have to write one on your own, and this will get you a setter function for all the fields as well. Okay, that is one thing. Another thing is ID, right? ID basically means over here that this is sort of going to be the primary key, because I told you, right, this whole structure is going to be reciprocated as a table. Okay, so that is why you would need to sort of make sure that you have a unique ID defined, right? And then for this attribute only, I'm going to use generated value strategy is going to be generation type dot identity. Okay, what this means is that I would like to define values for this particular column, right, ID, but that is sort of is going to be like supporting simple primary keys. So to have sort of like a structure where I am able to define or support primary keys is when you use this structure. There are multiple examples over here as well to sort of help you with this, right, but I have kept it simple. Okay, you could also add something like this. For example, it's written ID over here, but let's say in the table you don't want it to be called ID. Let's say you want it to be called customer ID. So you could add a annotation like this as well. So in the table here it will be written as ID, but in the DB it will be called as customer ID. Okay, something like this you could add over here. Now similarly for this you could have another file which is bill. Okay, and then you could have appointment, right? And then you could have class as a doctor class as well. Okay, I can simply actually copy this and put it in the doctor class as well, because a lot of attributes are going to be same. Just a few differences over here. In this case, you can see the doctor will also have a unique ID. Doctor will have a name. Instead of gender, I am more sort of concerned about the speciality of the doctor. Okay, and you could add more attributes here as well as if you want. For example, what are the working hours of the doctor, right? The gender and like the age also. Anything that you want to add. Because we are creating a simple CRUD application, my idea more is to explain these concepts to you and less on, going into too much details which may not be very useful. Okay. So this is there. Next, what you could do is you could go to the, similarly define the bill class as well. Okay. In the bill class also, you will have this part, primary key ID sort of will always be the same. So you could have a ID, you would have a patient ID, right? You will have every bill will have a amount, right? So you will mention the amount. Okay, and then you will also mention the status of that bill, whether it is clear or not, something like that you can use. Okay, and parallelly you could have something like this for appointment as well. Okay, every appointment will also have an ID. Every appointment will have a patient ID associated with it. Okay, every appointment will have a doctor, and every appointment will sort of, let's say I'm adding one more attribute, which is the date. We'll have a date assigned to it. You can add more if you want, but this should be good. Okay, once you are done with this, right, you have, I think, pretty much everything in place now. Just do one thing, just create a DB first using terminal. You just create the command create database. Okay, and then you could just mention the same name which you mentioned over here in application.properties. Okay, hospital DB, just mention the same name, hospital DB. Okay, that will simply create the database for you. This is a simple command for creating a database. Now let's try to start SQL Workbench again, right? And what should happen actually is the moment I really go and try to run this, right, automatically for all the files that are basically, or all the models that are basically created and they have all entity marked over them, try to run. And okay, I think it is there. Let's go ahead and check as well. And you can see here the hospital DB is there. Okay, and inside hospital DB you can see all the tables being created, and you can see even the attributes which are sort of mentioned are the same, or the columns which are mentioned are the same, which is sort of what we expected over here. Okay, so all this of automatically being done, of the tables being created, right, and of the columns being populated is sort of being done by this command over here. Okay, why? Because here we are using Hibernate. So what is Hibernate? If you already know about databases a little bit, Hibernate is an open source object relational mapping framework. Okay, so whatever sort of objects that you have created over here, appointment, doctor, bill, it will sort of map it to tables over here in my SQL. Okay, so Hibernate is that framework, okay, that is used for mapping a object oriented domain model to a relational DB. So that is how you will be, as a developer, you will be enabled with Java objects, rather than actually writing those SQL statements while interacting with the database. While we will implement the repository layer now, you will understand it better that for interacting now with the DB, we will not really be writing SQL queries. We will simply be using this object relational schema only to do that. Okay, so this command right over here, this property now configures sort of the behavior of Hibernate, of automatic schema generation. And when you do update over here, that means this or I project or Spring Boot or Hibernate specifically can create the tables also and update the tables also. If you will just to create over here, that will just give you the access to create tables. Hibernate can only create tables. But when you mention update over here, Hibernate can create the tables also and update the tables also. So this is very, very useful during the development to synchronize the database schema with actually the changes which are happening in your application without having to manually write the scripts. Okay, so I hope everyone has gotten here to this point to understand now that we have the models and all ready with us, right? The next step after this that we will move on is to write the controllers as well to make sure that the APIs are sort of available, right, to be hit by the user. So that is what we will move to next. But I hope at this point you know what JPA is, you know what Hibernate is, the models that we have created, and with that the Lombok annotations as well. Okay, and now we'll meet in the next video. Hi everyone, welcome back to the series of Spring Boot where we are building the hospital management system application. Okay, so far if you have been following the series, you already know that we have done already the basic setup of the project, and along with that we did set up a basic simple server which is listening at localhost 8080 as well. And then moving forward, we tried to define the entities, or you can also call this as the models for the particular project. Okay, we already do have a contract sort of a thing defined as well about what kind of API calls we will be having in our project, so that it's easier for a backend engineer to work on them and they know already what the expectations are when they are working on the application, right? So that is all done. And when we say we have been defining entities, right, we have sort of defined these models which will replicate into a table in our databases as well, which is being done very beautifully by Hibernate for us. Okay, and you have seen in the previous session in the form of SQL workbench as well that all these tables were created. Just one thing before we move ahead, because like I told you, we are going to be using Lombok over here in order to make sure that all the annotations, getter, setter that we have really added, we can very well use them easily. I have added annotation processor over here, which will sort of make sure that all the annotations that are added, we are able to sort of use them everywhere else in the project. Okay, now in this particular video, we are going to move ahead and sort of work on the very next part of the project, which is going to be the very first layer typically of our project whenever we start working on it. Okay, so I'm going to make a package over here and call it controllers, right? And under this, will have controllers for all the different models. Okay, let's say first file I create, I call it patient controllers. Okay, so I hope all of you already know about MVC architecture that we are following over here. Okay, when we say about MVC architecture, what that means is we have a model, we have a view, and then we have a controller. So what we are currently building right now is the controller. Okay, when I say controller, it can sort of assume or can be also assumed as the very first entry point into our project, into our backend project, specifically when we hit a API. Okay, so whenever I will show you later as well, when I will hit a API from the Postman, the flow of the code basically reaches the controllers first at the very first time. And then from the controllers, the logic moves on to the service layer and then to the repository layer, which actually interacts with the databases. So controllers sort of form the very first layer, which when you hit an API from Postman is when the flow of code reaches to. And then we have the service layer. Service layer is supposed to have the actual logic, right? Logic building is done over here. Whenever you have to work on something, right, and there's some calculation logic or something has to be done, it goes to service layer. And repository layer is sort of responsible for taking your request, right, whatever you want to get the data, turning it sort of like a SQL query and then interacting with the database. Even here, you'll learn something very interesting. For the time being, let's restrict our discussion to the controller. So here, to tell it's a controller, we'll again add an annotation, which is going to be REST controller. Okay, now here you can also sort of define that this is a controller. Okay, but what kind of routes will it really take? Okay, whenever hit from the database. So you know that, let's say if I talk about the patient, we have /patient sort of like the mapping that has been defined. To make it slightly even better, I will make it something like this /API/v1. The reason why I have done this is because you will see that, you know, sometimes product managers and, you know, the team or the engineering managers come up with a API contract. This is nothing but a API contract. This is like handshaking of how we are going to design the project. But later, sometimes some APIs expires and some new APIs have to be built. That is why we use the concept of versioning. Okay, so that whenever we know that if I am adding v2 in front of an API, that means there used to be a previous API for this, which is not in use anymore, and we are using its version 2. So this is sort of considered as a slightly better convention. So I'm going to do the same. I'm going to do /API/v1/patients. This is the route I'm going to be using. Okay. First, let's say, because right now we've not really learned about, you know, the service layer which we will be building. I will not really take the logic of the code to the another layer. I will simply do a log statement. For example, let's say I do public list of patients. So I'm trying to work on this API, get all the patients. Okay, here it is patient. Here I think you can see I have done patients. Here it is patient, don't need to fret about it. You can also do it patients over here. Okay, like there's no hard and fast rule defined it. As long as you're following the contract which has been defined, you're good to go. So here this sort of API call will return the patients. So I will do patients over here. Okay, and simply I will add a log statement over here. Okay, just to show you that the flow is actually reaching over here. Later, ideally there should be, in the ideal world scenario, which we will see later as well, the flow of the code should actually go to the service layer in this particular case. Okay, but we should be good for now, at least in currently. And I will have to import list as well. Okay, and since this is a get API, you could add something like this, get mapping, to show that this is the get API. If in the headers it's a get request, it is good. Let's say similarly we add a post API also, create patient. Let's say basically I am working on this, create a new patient record. Okay, so over here, here obviously, because you have to create a new patient, the user itself has to pass all the details, right? So in this case there will not be any request body, right? There will not be any input passed in the request, but in a post request the user has to sort of pass the body of the request as well. If you're not getting what I'm really saying, I would recommend to go and revisit the concept of REST APIs once. You'll understand what I'm trying to say over here. Then request body would be something like that, in which all the patient details has to be passed by the user. Okay, and here also you could do something like this, creating patient, you know, something like this. Over here you can do. Okay, to really show that you are working on this particular API, right? You may or you may not like add more APIs to this. This is just what I've shown you as a example. You are getting, I think, like a, okay, here you could just return, let's say the patient return null. In this case, these needs to have a return statement. Let's say here you sort of return the patient object only, which was passed by the users. Okay, so this is sort of like a simple, I've like a controller file I have created, right? You obviously have to add all the requests to it, right? But just to show you if this is working fine or not, first I will run it. Okay, let's see if for us MySQL dot servers space start. Okay, it is working. Let's try again. You need to make sure your SQL server is running, okay? Otherwise it will not be able to interact. Your code, the models layer will not be able to interact with it. So I think this is fine. Let's try to maybe hit the API as well. Here I've created a new collection. You can go over here, you can create a blank connection, and under that I have created another folder for patients API. So this is again localhost API. I will add /API/v1/ patients. This is what pretty much our API was, right? The flow of the code should actually come over here and the logs should show this. Let's see. Okay, so this was a status 200 API. That means it was able to connect to the controller layer. And there you go. You have the option as well. Okay, to create a good collection, always name the API as well. Rename of create, oh sorry, get all patients. So when you're working with a big code base, it's sort of easier for you to verify all of these as well. Okay, here I've just shown you for two, but you have to remember write for all over here, okay, and not just for this. So this is like create patient, and then that is get all patient. Let me write for others as well. Let's say you want to do this where you want to get patient by a specific ID. So in the request, right, in the path params, the ID should be there. So to be honest, all the game is of the annotations only over here. I feel in Spring Boot, it's sort of easier to work that way. Path variable long ID. Because like I told you, in the path params, you're going to have the ID. So that's why path variable. Here also you could add something like this, fetching patient. This is just for testing, okay? Ideally, we are not really going to add all of this log statements. You can add it if you want to do some logging, or even for that, I would recommend to use some logger libraries. This is just to show you that the flow is actually reaching over here. Okay, and here you can do something like this, which will make things all the very easy. Get mapping this, and then you mention slash, and then this is sort of like a variable container in which the ID will be passed. So the API will be slash API slash v1 slash patients, and then the patient ID will be passed. Okay, this is how you are supposed to do this. We have a put request also. I'm doing this for patient, right? And rest all doctors, appointment and billing. It is pretty much the same because you can see it's the same APIs, but I will still show you for the complete patients. Public void. Let's say I want to delete a patient. So delete patient. Again, in the path params only, the ID of the patient will be passed, which needs to be deleted. I'm not adding a log statement over here. This is just to show you the annotation. So this will be a delete mapping. Again, pretty much the same thing what we have done over here. Okay, this will not actually have a return statement because we are deleting. Okay, similarly, you can add a put API also. Let's say you want to update a specific detail about a patient, you could do update. Okay, and here instead of delete, you can put the put map. Okay, so this is how pretty much you have to define your controller layers for your entire project. Similarly, you do it, you create another file which is appointment controller, and literally the code will pretty much be the same. Just replace this with appointment. Okay, why? Because you can see even for the APIs over here, right, it is pretty much the same. Post, get, put, delete. Post, get, put, delete, right? And even the conventions that we are following is the same. It may not be usually same in all the scenarios because here the objective is to learn about a basic CRUD application. That is why we have used this over here. Okay, similarly you make a bill controller as well over here. Okay, and similarly you make a appointment controller. Okay, so make sure you do not like move ahead to the next video already, right? Make sure you have already created all the controllers and then only you move ahead to the next video, right? It will help you to understand while you are working and watching the video as well. Okay, I am doing something, and obviously in the next set of videos you'll see me already written this code as well, but when you try on your own you learn a lot of more things, you get a lot of more questions which you sort of work on. Okay, so this is what my recommendation will be to all of you, right? In the next set of videos we will now then move ahead and work on the service layer. But make sure once you have created, for example, a bill, appointment, or like a doctor controller, you test it out as well, like how I did. Okay, create a new collection, very beautifully sort of segregate everything. For example, here now if I have to add a request, not request actually, I will add first a like a folder, add folder which is, let's say, bill APIs. Okay, try to segregate your code like this. This makes it actually a lot prettier in how you are working. You can actually write a small documentation if you really want as well. It will be even better. I have made it inside it. We have to make it parallel. Okay, so you can create 4 folders over here and then try to see if the flow of your code is actually reaching the postman API call is reaching the code or not. And then you know that now it's really connected. When you're making a call, it's really reaching to the code. Okay, so this is actually much for this video, right? Make sure by the next video that you watch, you've already written these controllers, and then you move ahead and move to the next part of the code. All right, thank you so much for watching this one, and I'll meet you in the next video. Thanks. Hi everyone, welcome back to the series of Spring Boot, where we are continuing building our hospital management system CRUD API application. Okay, so in the last session I already showed you how you can actually build a basic, I would say, a controller class for patient, and then you were basically asked to reciprocate that logic for all the other controllers, 3 other controllers that you have. Okay, if you were able to do it successfully, this is how pretty much it should look like for all of you, right? Exactly the same, just that I have changed over here this part to appointments, right? And everything is literally the same. If it's a request to create an appointment, you have to take the input of the appointment parameters which are mentioned over here. Okay, that is how you will be able to successfully create an appointment. Don't worry, when everything is put in place as well, we will actually use this APIs and test these APIs as well to see if everything is working fine or not. Similarly, you could do it for the bill as well, right? Where you have mentioned all of the APIs, and for doctor as well. Okay, so I hope everyone was able to sort of design all these controllers over here. Okay. Next, now we are going to move ahead to our service layer. Okay, service layer is actually the flow of code which sort of comes after the controller layer, right? Once your flow of code moves from the controller layer, it moves to the service layer where the actual logic, if there is any, that will come into place. Okay, so here you make another folder which is package. You mention a service class patient service. Okay, so first start with making this new class, okay, over here. Now again, similarly, every controller will sort of interact with a service layer ka function as well. So corresponding to our controller layer, we will have a service layer as well. Okay, so it could be something like this: public list of, let's say, patient, right? And this will be get all patients. Okay, so what will happen is, ideally from the controller flow, when we click on the get all patients controller, basically this API itself, from the controller, the flow should move to this particular function of the service layer. Okay, here I am going to add a try catch block as well. Anyway, adding try catch block is a very good practice to sort of make sure that, let's say, while handling the logic of the service layer, right? Because this layer is also going to interact with the repository layer, correct? So while doing that, in case if there is any error, we should typically know that. Let's say, just for testing purpose, I add over here as well into service layer. Although ideally in this place, we should have the logic to interact with the repository layer. Okay. But just for simplicity, I have added this over here because we have not really talked about the repository layer yet. And then you could just do null over here, right? You could also do e dot set. You could do e dot here. There should be a function, or let's say you want to see the message, e dot get message, right? And let's say you want to print it, something like this you could do. Okay, you could mention error message. Let's say for like later you want to look at what the issue was, right? So you could add something like this, okay, to basically see what typically the error was. Okay, here you will need the class as well. Similarly, you could create all the other functions over here as well. Import java dot util dot list. Okay, now you could create similarly for by id. Okay, and again similarly you could add a catch block here as well, where you are sort of catching the exception, right, and sort of printing it over here. Okay, so this is basically what typically the service layer would look like. Here it will ideally interact with the repository layer. Okay, but we will come to that later. First, let's actually, once we have defined the service layer, let's actually connect the service layer with the controller layer first. Okay, now in order to do that, we will have to do a couple of things over here. Let's go to controller. Okay, patient controller over here. And now first I will write something, then I will explain to you how it is working. I will do private patient service patient service. Now in order to use the service layer over here, especially the, I would say the patient service layer over here, you would need the object of service layer, right, in order to be able to use it. So that is what pretty much we will try to get it over here. Okay, we will import as well. Import form.example.demo dot service dot patient service. Okay, now this is what we'll do, but that is not enough. On top of it now, we will add this auto wired. Now you must be wondering how just by writing auto wired as a class object, or I would say attribute to patient controller, how is this really working? Okay, this will typically give us the object of the service class, patient service class over here. Okay, so what actually happens is auto wired is basically a annotation in Spring framework that is used for automatic dependency injection. Okay, what that would basically means is when we say automatic dependency injection, it basically means we are telling Spring to automatically provide the dependency of a class attribute when creating a instance of this class. Okay, so the moment you put auto wired over here, it simply means that whatever attributes, let's say there are more attributes over here. Okay, let's say private a, private, let's say int a, int b, something like these. Okay, that simply means whatever attributes have auto wired on top of it, right, we tell the Spring framework to automatically provide the dependency of these class attributes when the instance of this class is created. So basically the objects of this will automatically be created. Okay, now another thing is, how does this really work? Okay, so what happens is when your code basically builds, Spring as a framework basically scans the components, right? All the classes which are annotated with component, service, repository, it basically checks all of them in your application context, and whenever it sees a class or encounters a class with auto wired annotation on any attribute, it searches for the object. Here in this sense, you could also call it like a bean in the Spring world, right? It basically searches for a bean of the required type in the context and basically injects it into that attribute. Okay, in very simple word, what actually happens is anything which has auto wired written on top of it, right? Anything which has auto wired written on top of it, what will happen is the moment your code will compile, okay, the moment your code will compile or it will try to build, right, it will see what all has mentioned component, service or repository mark. Here you have to mark it as a service as well, this I forgot. Okay, whatever is being marked with either component or service or repository, which we are going to take a look at later, right, and whenever it will see auto wired written on an attribute with it, it will search for the object of that particular context and try to inject that attribute when the object of patient controller is created. Okay, so auto wired is specifically commonly used in Spring applications to basically inject dependencies into components such as controllers, service or repository. Meaning in controller layer, we injected the dependency of service layer. When we will use service layer, we will inject the dependency of the repository layer. Okay, and why are we really using it? So I've mentioned what is auto wired, I've mentioned what does it do, I have mentioned also how does it do, right, how does Spring basically gets it, and we will also mention why do we use auto wired. So the moment or the reason to use it is that it simplifies the concept of dependency injection, right? Without having the person to manually create the instantiation or look up for dependencies. If I will sit now, check all the attributes required, create all those objects, I would say inject it into the constructor, it is a lot of unnecessary work for me, right? So auto wired basically takes away that dependency from me. Otherwise, what would have happened is, otherwise I would have done new patient service, right? And whenever the new patient controller object would have come into the picture, I would have to pass patient service as a object over here, right? And then sort of try to assign patient service equal to something like that I would have to do, right? Which is completely unnecessary, not at all required. Auto wired basically simplifies that for you. So this will reduce the boilerplate code and make your code more readable and maintainable as well. An example is what you can see over here. So the moment you do this, you have the object for patient service. Now you don't have to really do anything else with it. You are pretty much done. So now from here, you can take the call to the service layer. Do patient service, the object, dot, call its function get all patients. Okay, so now the moment the flow of the code comes over here, now we will pass on the flow to the parallel function in the service layer. Okay, this is what will basically happen. Let's quickly test this out as well. I will do view, or let's try to build the code all together. Let's see. We will try to build the code now. Okay, it is building very well. Now let's try to hit this API. 200 we got. Let's see the logs. See, you were in the patient controller, right? In the patient controller class, we had this log fetching the patients. Okay, and after that, because the flow had to go to the service layer, we went to the service layer because the logging of the service layer, which was into service layer, also came over here, right? So far, so now what you have done is you have the controller layer, and now the controller layer through dependency injection is now connected to the service layer as well. Okay, this is just one function that I have shown to you, right? Similarly, you can create all the functions for all the controllers. I will complete it for the patient class. Similarly, you try creating it for the other entities as well, which is appointment, bill and doctor. This is create patient. When we are trying to create something, the patient object will be passed to us. Okay. Ideally, again, like we did in the controller layer, in the next video, we will replace it with the calls to the repository layer. Okay. Delete a patient should be void. Delete a patient, and here the ID of that patient will be passed. ID is sort of like the unique identifier for us. Okay. Then we have delete patient. Then we have update patient. Update patient, and we return the patient object. Okay. Something like this you can add over here. Try catch block, just to make sure if, like in our case, there is not so much logic which is happening over here, but when it does, we need to make sure that we have sufficiently handled it well. And correspondingly, now change in the controller class as well. Okay, so basically here now the flow is basically going to the service layer. Always and always from the controller, it will go to the service layer. Create patient. Okay. And whatever is the patient object passed over here will be passed to the service layer as well. Here also we will do the same, and I will do get patient by ID, and I will pass the ID which was passed to the controller, which will also be passed to the service layer. Here also I will do delete patient, and the ID will be passed. Nothing is supposed to be returned in this case because we are deleting. You could obviously pass in like a message saying that the user was successfully deleted as well. Okay, you could do that. And you could do update patient. Okay, something like this. And now all the APIs of the patient class is now connected to the service layer. Okay, similarly, you could create over here a file which will sort of be the new class, which is for the appointment service. And then you could add for the doctor service, keep the S capital over here. Okay, and then similarly for the bill service as well. All right, so this is how typically you will create all the service layer. Again, like controllers, very similar to other controllers. This will also be pretty much the same. Make sure you do add this @ service to make sure that we are very well connecting the layers like we should. Okay, so this is what pretty much we learned in this session today. We learned about how do we create a service layer, right? And then we also understood how do we do the connection, and how does the concept of dependency injection work through the concept of @auto wired, right? And now very well, the flow is coming from the controller layer up to the service layer. In the next set of videos, we'll first talk a little bit first about logging, right? I feel like in order to make sure a code is very easily able to debug in case of any issues we come across, we need to add appropriate logging. So in the next video, first we'll add appropriate loggings in our code. We'll talk about a logging tool which is very popular in Spring. We will integrate it in our code, and then we will talk about the repository layer which we have to configure over here, so that then everything as an entire project is being stitched together. Okay, but I hope at this much point you're clear, everyone. The best way to sort of make sure you did understood everything that was supposed to be done is to sort of work on these rest of the layers and the codes that you have to write. Anyway, in the next video, you will see all these service layers written as well. But before you move ahead, I would really appreciate if you just try to create ones on their own as well to see if everything is working fine or not. Okay. Thank you so much for this video, and I'll meet you in the next one.